Is everyone able to see?
Yes, we can.
Okay. Okay, good morning and good evening, everyone. We were developing the template for doing linear regression modeling. And I'll take you through what I did. And it's going to be somehow interactive. So if you have any suggestion or any addition, you can just feel free to interrupt me anytime. So we can refine this template and make it a little bit better and intuitive for everyone to use. So I used the R Markdown, and then the first chunk, I just installed some packages, and this chunk I updated it as time went on, as I was developing the template, just because there are some of the packages that I had to install for to make my job easier. So these are a couple of packages. So you can always use this chunk to update or install any package that you want in the while you're working with this with the data. So the sample data set that I chose for this was the nutritional examination survey that's done in the US, and it had 10,000 patients, participants, sorry, they're not sick. It's just a survey. So 10,000 participants, and let me see if it's a readily available data in the package NHANES, and I visualized it as 75 variables, and as I said, 10,000 participants. So I chose BMI as an outcome for this one. And with this template, we have the question we are answering, or the thing that we are working on is predictors. I just chose like 6 predictors or covariates, let's say, of BMI, demographic and behavioral. So I chose age, gender, race, and then physical activity, alcohol use, and smoking as predictors of BMI. So for linear regression, just to remind you, I know you might be familiar with it, but linear regression can be used when you want to model a continuous outcome or a dependent variable. So for something that is numerical, let's say age, if you want to model BMI, if you want to model maybe something other common, maybe anything numerical. So there are maybe temperature, maybe, yeah, there are a lot of, but I know it's not common in health data. Most of the time we usually model a binary outcome, maybe someone who has a disease and doesn't have, or has a condition and doesn't have, or is doing that or not, or satisfied or not, things like that. But sometimes you might come across modeling a continuous outcome. Yeah, I've seen data in most of the time of HIV. In HIV data, they model CD4 count or viral loads and all that, and they use linear regression. So it's not common, but you might come across it. So in this case, we have BMI, and then we are seeing if age, gender, race, physical activity, alcohol, and smoking can factors associated with BMI. Okay, so I started by, after loading the library, I visualized the data, and that's why I knew it had 10,000 observation and 75 variables. And the head function is good because you can even see, just get a picture of how the data is by looking at the first few rows. And does anyone know any other good way to visualize? Maybe we can add here. The
You
data.
could use the function, the one that's called structure, str. It's gonna give you a few examples of all of the columns. It's gonna give you the type of the data as well.
Okay, let's try that. Yeah. So this
Bit
is my.
easy, but it,
Yeah.
it does do the trick sometimes.
Okay. Yeah. Yeah, I think it's also nice to see. Yeah, it even gives you the type of variable as a factor, integer, or numeric, which is also nice. So, okay. After that, I wanted to do descriptive statistics to see my data. So, and the variable, so I started with the outcome itself, which is BMI. So I just summarized BMI to see. So I saw that the mean was 26. The maximum was 81, which is very, very high, to be honest. So this can give you an indication. Maybe there might be some extreme values in this. And that could affect modeling. But we can also see the distribution. So it's important also to see the distribution. Yeah, because also the minimum is 12, which is very, very low. So maybe there are some extreme values, but we can see so I wanted to do the Shapiro-Wilk test just to see how normal is this variable. So I didn't get the code yet, but that sometimes helps in linear regression. It's like it's not a direct assumption, but mostly it's just like like an understanding people have that when the outcome is normally distributed, usually the residuals are normally distributed. And we'll talk a bit more about that later, but it's not like scientific proven, but it's like an indication. So some of the things that you have to take into account in linear regression is the extreme values usually have influence in the regression line. So they usually affect, yeah, your estimates. And then also to take into account the distribution of the data of the outcome can affect
So,
your
Edwin, you're coming to a very good point. That understanding the distribution of your outcome is key, and it's the first thing you have to do, because if it's not normally distributed, you need to adjust it or change the family of your
yeah.
modeling. Now, the outliers or extreme events, as you're calling, it's also very important. In those, while the main way to address those is to excluding them, the reasoning to exclude data is gotta always be somehow uh, explained upon. Is it faulty data? Is it very weird cases? So in the end, I think in the template, we would like to have a section for sensitivity analysis where one of them is adjusting for outliers and
Okay.
seeing how the model performs with outliers. If the model is vastly impacted by outliers, it means that there's a big impact that we need to address somehow. And maybe the true sample is the one without the outlier. And that needs to be discussed or at least understood in the reporting of the data. Okay.
I think, okay, I'll work on the outlier, on removing the outliers and see.
Yeah. And then I also want to make a point that the Shapiro-Wilk test, as much as the Kolmogorov-Smirnov test, those are tests that allow us to test the hypothesis of a normal distribution, but you shouldn't necessarily follow them to decide, because sometimes you have a distribution that deviates from that a little bit, but you can still fix it. And I'm not very comfortable with using test statistics as a reference to decide what kind of distribution you have. You should always measure that with the test statistics, but also looking at the data and then finally looking at the different sensitivity of comparing your model with other models if you think there is deviation.
Okay. Yeah, I think
Okay.
of course I agree that the Shapiro test is very sensitive to many minimal deviations of normality and sometimes can be misleading. So yeah, I agree with that.
Yeah, and I think that for somebody without the same amount of experience as you and I, they could take the test as a reference of truth, which is what we see a lot done. So yeah, I did the Shapiro-Wilk test and I'm fine, which might not necessarily be true.
Okay.
Okay.
So yeah, let me just move it out. Yeah, so I plotted the histogram to see to visualize the distribution. Yeah. So yeah, so also plotted the histogram. Yeah, and you can see there are some extreme values here, though it seems like it's a bell-shaped. So it might, yeah, I know. But there are some extreme values, as you can see here. There are few extreme values. Are there any other additions here that you might think we can add in this? Maybe I can add the line, right?
Well, yes, exactly. I was going to say that if you were able to tweak this plot a little bit, it would be good to see where the median and the mean lines are. That is a very good marker to see how normal the distribution is. If it's normal, then the mean is going to be somewhat coinciding with the top of the histogram. If it's really bell-shaped,
Yeah.
and theoretically, the mean and the median will be very similar, if not the same.
Okay. Of course, we have seen they are like similar from the summary. But yeah, I think I'll add
Right.
those. From the summary, it's like 25 to 24, so it's not
Yeah,
bad.
they're pretty similar. Yeah.
Yeah, okay. I'll add the lines then. Or should I add them right now? I'm not sure about the code.
No. You can do it later. I think we're just getting feedback.
Okay. So also checked the other variables which I am going to model. So sorry about that. Yeah, so I checked the other covariates. One was age, and so I just summarized age to see how it is. Let's see here. Where is it? Yeah. And then I did a box plot for age just to visualize. But we can also do a histogram because it's a continuous variable. Yes. And then the other covariates were all categorical. So there is this function of table which is which is known. that summarizes, this is age, sorry. This was supposed to be gender. Just put gender here. Yeah, so there is this. And then I found another function from the janitors package, of which can give you frequencies if you want to review frequencies and percentages too. So it gives you frequencies and percentages, which is kind of useful and more intuitive. Though you can do that later on the GT summary table, but this can just give you a quick summary of the frequencies and percentages. So you can choose to use any function, the normal table, or install the janitors package and then use the function table with the YL. Then easily you can get, you can summarize the categorical variables. Is there any other common way of summarizing that you might want to add?
No, and I think for the sake of reproducibility, Edwin, at some point we will want to have a template to build descriptive tables, and then that template to build descriptive tables will also include will be used on the other templates like this one. So it would have one straightforward way to do tables instead of having multiple, because we want people to get used to do one thing that the group does, and then later we can change if we find something better. But the idea is to give people one solution that does the trick right.
Okay, yeah. So I think, yeah, I think, yeah, we can work on that. Just a descriptive template. I think, Joe, you have it, right? Joe Viter.
I might have some.
Yeah, then we can also just always link it whenever someone needs to in all the on all the other templates for a deeper one. Maybe present it one of the days. That would be nice. Yeah.
Up for grabs. Anybody that wants to do, this is your time to shine.
Yeah, that would be really cool. Yeah, there are a lot of things that I think, yeah, I've not covered here. The missingness stuff, the plots, all of the other nice plots that you can do. The chi-square, the t-tests, all the other ones. That would be really nice to do. Yeah. So yeah, I went directly to after seeing the covariates, and the outcome I did, I just did a univariable regression with age, just with age. Let me just run it here. Yeah, let me run it. Where is it?
I think you need to run the summary, right? To see the
Yeah.
output.
Yeah, yeah.
Yeah, there you go.
Yeah, so this was the output. I interpreted it here. So just as a reminder, the coefficient here, about the coefficients, I'll start with it because that's the important one. So the intercept is just the BMI when age is 0. It's mathematically true, but it's not doesn't make sense in real life. But we always try to center the value, the age. We always center it so that it can make sense. When centering is just subtracting all the values with the mean, so that when you model it, the intercept would be the BMI when age is average. or the BMI for an average aged person. For here, it will be like, I think 24, if I'm not mistaken. Let me just go back. It will be like 24. Yep. I think 24 or some 24 years. For a 24 years aged adult, the average BMI would be that one if you center it. But this one, you can interpret it directly as when the age is 0, this is the BMI. So it is 21. And the coefficient age is a unit increase in BMI for every year increase in age, or every unit increase in the covariate. For here, it's in this case we modeled BMI with age. So for every year increase in age, the BMI increases by 0.13 points. So it's a small increase, but as you get older, it seems your BMI is more likely to increase. The standard error just is used to obtain the confidence intervals. And then you have which are the 95 confidence interval. There's just a simple function to get it. And this one is the statistical test for the T, which is the T test is used here in modeling to test the hypothesis that the value you are getting is different from the null, is significantly different from the null, of which here the null will be 0. So the question that the model is trying to answer is the value you are getting here, the 0.13 difference, for example, is it significantly different from 0 or not? So that's the t-test that is used, and you get the p-value for it, and it's really, really small here. That's why you see it's less than 2 times power of x16, which is very, very small. Seems that it's very significant. And this can happen with bigger data, with really big data, because you're actually more likely to get a representative data from the population, and with enough randomness, of which you get the p-values really, really small if there is a significant difference. Does that make sense? So hopefully it makes sense. Are there any questions? Sorry, maybe I'm moving a little bit too fast.
No, you're doing great. I like how you explained each of the outputs from the summary there. It's always important. We often consider this part to be simple when you are used to fitting models, and we maybe skip the part of actually looking at the model output. So I think it's very important that you have it there.
Okay. Okay, then in this, the first, I wasn't able to obtain the 95 confidence interval directly. So I used another function from the Broom package where I can just do it in one line. This is just another way of making it more friendly, maybe eyes friendly, I guess. So with this, you get like a table, which is much more intuitive to especially to someone who's not used to statistics, and all the important stuff are there. And the p-value here is 0, I think, because it's very, very small. So that's why it's equals to 0. So you just put less than 0.001.
So I really like this way of showing the results. Now, in the template, in the end, we want to have a code that transforms this into the table we're going to put into the paper.
Yes.
Okay. So as a
Yeah.
way, as a step to inspect the model, I think it's fine. But if we can combine all this flow, the way you're presenting, which I really like, and you're doing very well, is more as if you are teaching us about the topic than necessarily if this is the template. In a template, all of these codes would lead to the report that would have the descriptive data, the histogram, the descriptive analysis of all the covariates, and then the table with the model results for you to inspect it as a report, just to make things easier. Like, we want to try to make this more something that spits out the solution instead of the step-by-step piece. But yeah,
And yes,
let's
yeah,
let's try to make that in the next iteration. But I think as a structure of the template, this is looking great.
okay, yeah, yeah. So I have yeah. So after modeling, I plotted the regression just to visualize the scatter plot and the regression line. As you can see, it's increasing, though not so much, and the residuals seems distributed across the regression line, well distributed, maybe not equidistant, so equidistant. That's just, this would maybe fitting the assumption of ecovariance. So there is some assumptions which I'll talk about that have to be met when you are modeling linear regression. But one of it is homoscedasticity or ecovariance, of which in simple terms, we expect these dots outside the regression line to be equally distributed across the regression line. So this is one of the way to visualize it, and you can see it. It might not be perfect, but it can be an indication that the assumption is met in this case. So there are some other assumptions we can check using this function of plot, which it will plot the residuals. The residuals are the other values that are away from the regression line, or the observations, let's say, and then you can take them and plot them and see if we expect for a linear regression, we assume that the residuals are normally distributed, have ecovariance, and what other assumption? I think there is another one. There are three of them, I think, for the residuals. So you plot the residuals versus the fitted values, and then you can visualize and see if the residuals assumptions have been met. There are some other tests that can be done. For here we have the QQ plot, which this one test the normality of the residuals, which in here it's supposed to go hand in hand with this baseline, of which here we see there is a small deviation, but I think this is okay for modeling for this assumption. I think it's not bad. And the other ones are for let's see. So the other plots are for the I think this one is ecovariance, residuals with the fitted. As you can see, it's along also the baseline, of which it seems that the assumption is met in this model.
Yeah, this model seems to be right. Of course, this is a large data set. So when you have large data sets, models tend to perform better,
Yes.
although there is some variance. At the same time, because it's a large data set, any variance would be, or any variation would be something I would be a little bit cautious about. But I just want to point out, Edwin, that João sent out a GitHub set of codes that would create a very nice set of diagnostic plots that I think
Okay.
we should integrate.
Okay.
Okay.
Yeah.
I don't think
Yeah.
all of them. I don't like all of them. I think the plot with the model performance is what we were looking at. I think this would be
Okay.
good diagnostic plots. The other ones are not that good.
Maybe they are just academic, right?
No, they're just like some random
Okay.
stuff
Yeah.
here that I don't think is very valuable.
Okay. Yeah. Okay. Yeah. So I was continue building it. So as you say, Joe, I wanted to do a univariate crude or crude model, then a multivariable, then try to combine it using GT summary. That's
Yeah,
what I'm.
yeah.
Then after that, maybe check. I'll add the assumptions here, the
Mhm.
important ones. So you said which ones are the ones important to check? Maybe should we include in the template? I might
From,
just.
from that link that I sent, Edwin, the package is called performance.
Okay.
And the function that I think that Ricardo was talking about is the function that's called check underscore model. And what it does, it plots for each type of model. If it's a linear, it's a binomial, it's going to do different things. But does like posterior predicted check, checks for linearity, homogeneity of variance, influential observations, collinearity, and normality of residuals. So it's a single function that's going to do all the plots for you, and it's quite reproducible for the other analysis we're doing. So
Okay, I think I'll add it here. Did you send it to the via email? Maybe you can forward
It,
it if I missed
it's on
it.
the Zoom chat, but we'll share by email.
Let me see. Yeah, okay. Yeah, I didn't see. Oh. Yeah, then I'm going to combine the tables then.
Yeah.
I'll do the univariable and the multivariable table and then combine the two tables. Then check the assumptions. Is there then as you suggest the sensitivity analysis with removal of outliers. Just to see. Is there
Yeah.
anything I need to add here? That would be important for the template.
No, I think this is pretty good. Yeah, there's gonna be a discussion around how you build the model, but I think that is beyond the goal of the template. The goal of the template is the tool. So the tool here with the things you need to do. The discussion around how you build the model, how you choose your predictors, if this is a confirmatory model versus an exploratory model, and what are the differences in how you interpret this? These are things we have to put on the SOP later. So for now, I think this is good. If you can then streamline this so that in the end it produces, it's fine if each chunk has its result, that's totally fine. But by the end, we want to have this spit out a report that we can use to paste to the document, to the paper, wherever we're going to put this out into.
Okay, I think maybe I could figure out a way to do that. I'm not sure if.
Yeah.
if
Yeah.
you build the tables, Edwin, for instance, with 3D summary, you can save them to either a docx format or to a PDF or a PNG. That's to have something that is going to save it, and we can use that in a manuscript later
Okay, I got
instead
it.
of needing to type everything again.
Okay, got it. Are there any
Yeah.
other questions, maybe? Something we can discuss in linear regression?
No, I think this is looking great. So the way we see this is that by what we want to do is that this is one piece of the puzzle of building your analysis plan and your analysis code. So this output you're going to have that reports out the regression results, when you're building out the analysis plan, you're going to have different pieces of different templates pulling in together, and then you would report out the results to the rest of the team. That's kind of how we want to go through this, as making it complete. So this is looking great, Edwin. Thanks for guiding us through, and thanks for the work on this. And this is exactly the type of work we're trying to do and want folks to engage with. Cool. The good thing is that once you have the linear regression model, then it's a small jump to get for all of the other GLMs. That's good. Thanks for working on it.
Okay. Yeah,
Great,
it's
great.
great planning. Yeah, I think it will be very useful in the future.
Oh yeah, oh yeah. That's our December month. It's building this out. As a reminder, you have until November 15 to enroll on our template building marathon. That's going to be the end of the year. If you don't enroll by the 15th, you're not going to get the swag. And you're not going to be involved in the work, of course. So that's that benefit for you. And we're not going to say thank you in the end.